Good morning, YouTube. Another solar project update. Found these 450 watt panels for $20 each on Facebook Marketplace. And they're just too good of a deal to pass up, so I'm expanding the solar farm. And so I got a good deal on it because there's little cracks in it that I've sealed up. So this one's cracked all the way across. As you can see, I've siliconed it. So that was my first step, is to clean them up and seal them up. And so I just gobbed it on there and smeared it flat with my finger. And then these frames are 100% recycled material. So the screws I got from a deck job I did for a lady, and then these I got for free from an electrical company, and then I got this wire as scrap from a friend that I asked for. And so I got all this stuff, as you see, for 40 bucks. But I also had to go drive and spend another 40 bucks on gas and all that stuff. And then I spent all day yesterday making them. So what you see are basically two 450 watt solar ever panels. I actually met the owner. He was super cool. He hooked me up with these and we talked for a bit and I shared some information and he listened, and which was nice. Um, so solar ever, and they're bifacial. They're 35 volts plus or minus 3.5 percent. So what I'm going to do is I'm going to string them in parallel, meaning that I'm going to attach this positive here to this positive over here, and likewise the negatives, and I'll have a Y coming off to my microinverter input. All right, so let's go back to these frames. So if you want to do this project yourself, what you'll need is a hammer and some sort of pry bar to take apart the pallets. And that makes it super easy. So you'll just like pop that in there, hammer, and then it pries right up. And then once you get it taken apart, you'll need a measuring tape, mark it to length, and then a way to cut it. So something like that, or even a handsaw. I was using a handsaw for a bit. And then I used Sawzall to clean up some edges. If I didn't want to measure it and I just slapped it on there, you can just cut it. And then I can also notch out stuff like that. But that's kind of optional. And then, of course, you'll need your wire to wire in the frame here. Get something with high tensile strength, or just use whatever you have. If you live in somewhere with a lot of wind, you're going to have to get something that's rated for wind, like straps, not just this. I don't live in a place that justifies that, though, so I'll be okay. And then also, if you live in a place with a lot of wind, you're going to probably want some sort of top rail here to mount to these two spots as well, and maybe even add a spot in the middle to connect to, just to make sure that this bending moment doesn't break your panel. And then you should have everything you need to complete this project. Obviously, you're going to have to either wire custom Y or buy one, right? And then box of screws or something. Let's pretend this was a nail. What I like to do is I like to, when it's all the way like that, and if you can't get your hammer in there to pry it up, which is a pain if you don't have a cat's paw. If you don't have a cat's paw, what you can do is flip the whole thing over, set it on top of one of your pallets that isn't disassembled yet, and just hammer this boom, boom, real quick, and that'll stick up, and then you pry them all out at once. And then just get yourself a cup and throw them in a cup so you don't run over your stuff and give yourself a flat tire. Just two pallets taken apart. One was fully taken apart. The other was mostly taken apart. One side fully taken apart, and then the other side I cut in half. So basically, this is like one side of one. This was attached right to all these, and then I attached this side, and then the length going across, I just added going vertical, and then basically I utilized equal lengths going across this way, and if they had this little notch right there, I cut that out with the Sawzall to get more light coming in, and because they already had like this little U shape right here, as you can see right there, so that allows for a little bit more air and light to come underneath. And then you want these braces here to keep it true this way, and then the solar panel also locks in the top side, and then it keeps it true this way with the solar panel and this beam. So this is going to be, you know, in tension this way and compression this way, but it's mostly designed for intention, obviously, with how I placed it orientation wise. And what I'll do is I'll add a reflector down here on this bottom side right here so it can reflect back up, and then I'll probably add a couple feet of some reflective material right here as well to get it to come up. So this will be south facing, and it's at a ballpark around 60 degrees. It's pretty steep, or even more on that one, and then this one may be a little bit less, but I just made it as close as I could with the materials I had, which actually ended up being like perfect in length. As you can see, like this height, I didn't even cut that. That's just how it was. And then that same with this panel, just came out pretty much flush. And I didn't cut these ones either, which is nice because it's a nice handle. That's why I left it like this, so I can move it without like pushing on the panel. I can like put my foot against here and like rock the whole thing back, and I can adjust the angle that way. It's for seasons, for different seasons, or if I want to test, you know, what works best, I can rock it back this way, and I can just prop it up and stake it down. So that's the idea, is I'll just throw some stakes on this back side right here, and even put some sandbags all along this back corner, this back rail that it pivots along. And then, you know, I can put cinder blocks or whatever on the base if I want to, and I can also stake that down. But for now, I'm just going to keep it like it is. And I'm going to try it at this angle because I live where it gets snow, and I was noticing this winter testing that, you know, snow is definitely a concern, and I wanted to take advantage of the bifacial aspect, so that's why it's so vertical. And then to compensate for any shading on the underside, hopefully this reflector will kind of, you know, compensate for that. I also noticed you're going to need to clean your panels every couple weeks if you live in like a desert where it gets really dusty, or probably anywhere every few weeks at least, but like a quick wipe down. So that's why it's real nice and low to the ground. You know, like right here is a nice easy height for me to work with a brush especially. And so I'm trying to make everything as easy as possible. And then the nice thing is I can take a dolly, and I can just put a dolly right underneath here and take my hand, and I can just, sorry about that, I can just literally roll it around a little bit, which is pretty cool. It's definitely awkward, it's big, but it's still movable, and it's not too heavy. Yeah, so this will be 900 watts, which will be backfed into a micro inverter into the grid. And my meter is bidirectional, so that allows me to save money on my power bill. Right now I have 300 watts with my other microinverter setup. So that's where that comes in, right there. And this door was already kind of cattywampus like that, so I decided to to route it through right there, and it just the screw holds it there. And so that's the 300-watt system with the little supercap bank and microinverter right there. That's that box. So I have a 27-volt supercap bank on that one. It's 50 farads. And then this one is 200 farads, 13.5 volts. So it's 100 farads wired in parallel, 2 sets right there. And then this is like close to 70 amp hours of battery storage right here. And I noticed it even will say it's charging at night from the supercap bank since I've added it. And it turns on multiple appliances now as well. So like that's a 144 watt inverter. This is a 140 watt fan. Sometimes it doesn't like to run multiple things at once, but once this is going up to speed, especially, I can turn this on, I can turn my light on at the same time, usually for like hours. It even will turn on that fan and this fan at the same time. I don't know if it'll do it now because it was dead not too long ago, but let's see. So the nice thing is I can just check my voltage from inside with this system using this 5-in-1 portable power pack analog meter. And then on the outside, I can also check my voltage because my Z-amp charge controller, which is connected to these two right here, going out right there, has a display. So I can check the voltage from inside and outside. And so I'm working with 3 different panels, 3 different charge control systems. The Z-amp, we got my own custom MOSFET voltage cutoff with a small cap bank there. And then we got a buck converter, which is very simple. I just got a couple diodes coming off to this automotive fuse, and I added a diode in parallel to push more current through that. The reason why is because I wasn't really fully utilizing the system. Even this Z amp is capped at 1 amp, which isn't really utilizing its potential with the 80 watt panel. Really, I should have a 10 amp one. Anyways, what's interesting is I noticed this stopped charging the other day and actually blew my 5 amp and my 10 amp fuse. So basically this is a 2 amp fuse and it's like a cascade. I have like 10 amps to 5 amps to 2 amps. And the reason I set it up that way is because it's coming off the supercap bank and I didn't know what it'd be like. And it blew up my 10 amp as well as my 5 amp fuse, which is pretty amazing. So I had to replace those to get it to charge again. And I'm glad I added fuses into my system because otherwise I would have had to, you know, rewire and replace all of that. Would have been a big pain. But instead, you know, all I had to do was pop this in and out and pop that in and out. And I have it set it up to where it's like plug and play. You see that? So I can just plug that in and I can plug that fuse in. And I took all these wires off of microwave oven transformer capacitors. So you got to make sure you discharge them to stay safe. But that's where I got all these leads from to make my own custom plugins. And this is my own custom 11 volt, 4.6 amp hour, 1.2 volt battery charger. So you can see they're just the little AA batteries. I can slide in and out of these tubes if I want, and I can use them for my controllers or whatever. And when I'm not using them there, I use them as an 11 volt battery basically in my 12 volt battery bank. So I have like 2 of them wired together in parallel to make 4.6 amp hours. And then this has got a battery inside of it too. And it's all like lead acid. Besides this, I'm experimenting with lithium iron phosphate. But other than that, it's like lead acid working together. This is AGM and this is gel. So I would recommend, you know, get the same type if you can. But I have it primarily coming off the buck converter to this one with the supercap bank on the gel. And then this is set to the AGM setting on the Z-amp charge controller, which is primarily connected to this. And so the battery sees mostly those charge controllers, but they're all wired in parallel. So they all start to equalize and see each other. so they all work together. So, you know, if the Z amp will turn off first, basically, at like around 12.5 volts when it starts to see that it's overcharged, but it'll keep charging. And then this will shut off at 13.6 volts. And then the buck converter will keep pushing and hold at like 14.4, 14.5 volts and like trickle charge it the rest of the way. And then basically my supercap bank, you know, it trickle charges this as this dissipates energy because this is connected to the inverter all the time, but also manages and handles the load as I turn this on a lot better. And that allows me to run multiple fans. Here we go. It's going. It's not very bright outside, and it's not very charged yet either. And so once again, that's a 144 watt inverter. That's what it's spec to. That's a 140 watt fan. And yet this is blowing. You know? This is pretty energy intensive of a fan too. This charcoal filter inline fan, it's a 4-inch box fan. So I know it's like 65 watts or more at minimum. It's probably a lot more than that. But yeah, I just took activated carbon. That's another project I did. So I took a pant leg and I cut it and I shoved it in there as a sleeve, and then I surrounded that with a bunch of medium grade activated carbon. So I just bought Filter Zorb 200 medium grain premium activated carbon. You can just get that for like cleaning fish tanks or whatever, and I got it online for like cheap bulk. It's kind of expensive, honestly, but it's cheaper to reuse and replace that filter and make my own filters than just buying more cans over and over again. So that's how I do it. It smells like fresh air. All right, YouTube, thanks for listening.